This question is from GATE Mechanical Engineering of 2014. This is question number 49 of set 2. The question is, a heat pump with refrigerant R22 is used for space heating between temperature limits of -20 degrees Celsius and 25 degrees Celsius. The heat required is 200 megajoule per hour. Assume specific heat of vapor at the time of discharge as 0.98 kilojoule per kilogram Kelvin. Other relevant properties are given below. The enthalpy in kilojoule per kilogram of the refrigerant at isentropic compressor discharges. So this is the property table given below, and we need to find the enthalpy of the refrigerant at isentropic compressor discharge. Okay, let's see the refrigeration cycle first. So this figure represents the TS diagram of vapor compression refrigeration cycle. Okay, all the values are given to us. T1 is -20 degrees Celsius, which is equal to 253 Kelvin. T3 is 25 degrees Celsius, so this will be equal to 298 Kelvin. We are just adding 273. Now S1 and S2 will be equal, so S1 is equal to S2, the entropy at 1 and 2, and that is equal to 1.7841 kilojoule per kilogram Kelvin. S3G is also given, that is 1.7183 kilojoule per kilogram Kelvin. H3G is given, that is 413.02 kilojoule per kilogram. So now using the relation S1 is equal to S2, that will be equal to S3G plus Cp ln T2 by T3. Okay, so from this relation we can find T2. So ln, we can write ln T2 by T3. T3 is 298. This will be equal to S2 minus S3G. Both the values are given here, so this will be equal to 0.0671. Now T2 will be equal to 298 multiplied by e to the power of 0.0671, and this value will be equal to 318.56 Kelvin. Okay, so we have got the value of T2. Now we will find H2. So enthalpy at 2 will be equal to H3G plus Cp into T2 minus T3. Okay, so H3G is given 413.02 plus Cp. Now let's check if Cp is given. Okay, so the specific heat of vapor at the time of discharge is 0.98 kilojoule per kilogram Kelvin. Okay, so the value of Cp is 0.98. This will be multiplied by T2, that is 318.56, we just found out, minus T3, and T3 is 298. So this value, enthalpy at 2, H2 will be equal to 433.286 kilojoule per kilogram. Okay, so let's fill in the blank. The enthalpy of the refrigerant at isentropic compressor discharge is 433.29. We are rounding it off to 2 decimal place, kilojoule per kilogram. For more information on vapor compression refrigeration cycle, you can refer to the NPTEL course, lecture number 47, Heat Pumps 1 on Energy Conservation and Waste Heat Recovery by Professor Anandarup Bhattacharya of the Department of Mechanical Engineering at IIT Kharagpur. You can also refer to the lecture on vapor compression refrigeration cycle by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.